severe weather for the high plains, but we're also continuing the flash flooding from Northern California to Oregon, but also now for the upper Midwest and again Florida. Good morning, I'm meteorologist Pew. Today is September 9th, 2025. So starting with severe weather in the high plains, we only have a 5% chance to see an isolated risk for winds greater than 60 miles per hour and large hail. And throughout the eastern Rockies in general, we may see isolated storms around 2 p.m. mountain time, and those are going to travel eastward. And models are suggesting that we're going to see more intense storms around 4 p.m. mountain time, or that's 5 p.m. central time. And as these storms travel eastward, they're going to become more clustered and maybe form into an MCS or mesoscale convective system, or basically one big blob, and travel into Kansas and Oklahoma over the night. And from Northern California to Oregon, we're going to see isolated cells around 1 p.m. Pacific time, and that's going to last throughout the day and evening. On top of the rainfall we saw yesterday, we're going to see an additional 1 to 2 inches of rain. And for the upper Midwest, specifically northern Wisconsin and Michigan, you guys are already seeing remnants of last night's storms, and that's going to continue this morning, afternoon, and actually pretty much all day and all night, and maybe even into next morning. And models are suggesting that places like southeast Minnesota and western Wisconsin may see convection tonight as well. So in both these areas, we may see 1 to 2 inches of rainfall. So why this is all happening, if we look at 500 millibars or midway through the troposphere, let's start with the big cyclone that's in the west right now. And this cyclone or low pressure has been causing this trough in the west, but it does look like some of the shear has been pushed off to the east. But we still have two things going on for Northern California and Oregon. One, we have mid-level moisture that's been recycling around here. And two, we still have a lot of vorticity or spin, and that's really helping with the upward motion in these areas. Now skipping to the upper Midwest, we do have a shortwave trough, and as we know, what shortwave troughs are generally associated with decent shear, which is going to tilt those updrafts, prolong those storms, but also vorticity, spin, upward motion. And if we look at Minnesota specifically, we can see that there is a big dip in the height contours, which is telling us there's cyclonic flow or clockwise flow, which is telling us that there is upward motion in this area. So with the massive trough in the west and the shortwave trough in the Midwest, it's almost kind of squishing the ridge that's in the eastern Rockies. And with that, we're going to have perturbations or basically little disturbances. And these little disturbances are going to act like little pockets of vorticity or upward motion in these areas. And as the days go by and the cell starts forming, we do see some shear start developing as well. Now going down to the surface, for the previous few videos, we've been talking about a high pressure that's been in the Midwest and then travel eastward, and that's still present here. And so we're still having that clockwise flow from Texas, bringing in that tropical moisture into the southern plains, into the eastern Rockies, plains, and upper Midwest, which is why those in the Midwest that have been feeling all these cooler temperatures suddenly start increasing back into the 70s and 80s. And with that being said, we do have a low pressure that's developing in Colorado, and that's going to travel eastward, and that's counterclockwise flow, bringing in easterly winds, and some of these winds are going to travel upward with the terrain, and that's going to help with the upward motion or orographic lift. And for the upper Midwest, we do have a stationary front, which is why we're seeing a lot of consistent lifts and consistent storms being developed. And because we're having a lot of this tropical moisture being advected into this area, we're going to see more continuous storms. And that's why we may see